Here we first import these libraries. Flask. From this Flask we import a Flask render template request library, and eval main is a custom library in which only one function exists. That function's purpose is to find the intersection point of the given lines, and we have another library called time. If these libraries are not installed yet, you need to install it using pip install. Let's enter into the main code. First, we import the Flask library and create an instance of Flask class, which we name as app. Next, we use app route decorator to specify the URL route that this function should handle. In this case, the route is the root URL slash, and we specify that function should handle both get and post requests. Then we define a function that will handle this route. This function is named as index and it takes no arguments. Its main purpose is to read the inputs from the HTML file and pass on to the eval intersection function and get the results and send to HTML using render template. Inside this index function, we define four variables m1, c1, m2, c2. m1, m2, c1, c2 are all floats and they are obtained from the user's input through the URL parameters. As I said before, these HTML parameters m1, c1, m2, c2 are defined in the HTML file under the required name tag. If these parameters are not specified, the default values are 1, 2, 4 and 2.5 for these inputs. These parameters are used to represent the slope and intercept values of the two lines that we will use later in the code. Next, using these input values, we evaluate the intersection in eval intersection function. This eval intersection function is defined in eval main file, which is here. In this file, we need certain libraries called numpy, matplotlib, time and OS. It is a system library to perform some basic delete operations. Then we create a numpy array called x to generate x coordinates of the given lines. This range I have randomly selected. Then using the equation format y is equals to mx plus c, I calculated the resulting y coordinates. Then using these two formulas, I calculated the intersection point. Then we plotted and saved the figure in the static directory as plot.png. Then the line equations and intersection points are returned to app.py. From this we export to HTML. Upon receiving this line equations and intersection point from this eval intersection function, we export them to HTML using this render template function. After that, finally we check the name variable whether it is equal to main or not. This condition is verified to make sure that this file runs as a standalone script and not as a part of any module. And then we enable the debug mode by setting debug is equals to true. We set this debug is equals to true because in case in future if you face any errors, we can debug this file. That's it. Our web app is ready. After developing this web app, we just have to open conda prompt and go to the directory where app.py file exists. Then issue the command python app.py. If you issue it, a web server will start and it will give you a website address to see this local web app. Select this HTTPS website location and simply press right click. So upon pressing the right click, this website address is copied into your memory, and then open any web browser, paste the copied link onto the search bar and press enter. That's it, your web app will be displayed. Let's try solving some equations. For example, 1x plus 2, 3x plus 4. If you want to solve this equation, then the intersection point is minus 1 comma 1 and it looks like this. Let's try out another equation. 5x plus 4, 2x plus 4 and the intersection point is 0 comma 4. If you have any questions or need any help, you are always welcome to post them in the course discussion forum, and also you can always email them to elastropy@gmail.com. Happy learning. Thank you.